Hey everyone, welcome back to my number sense series. Today we're going to continue from last time where we talked about the GCD, the greatest common divisor. Today we are going to talk about the LCM, the least common multiple. Now I'm sure some of you can already figure out what the LCM actually means. It's the smallest number that is a multiple of these two other numbers, or maybe 2 or 3 or 4 or 5, but today we're going to focus on 2 because the ways that we use to calculate the LCM of two numbers can be very easily extended to those of 3, 4, and 5, and in number sense they're only ever going to ask you about two numbers at a time. So there are a few ways of calculating the LCM. The first way is to find the GCD first. Well, they all kind of involve finding the GCD first. So this is what we're going to do. Find GCD. Now, I am using the same numbers for all these problems that I used in the last video, so maybe you remember what they are. Now, just to recap, to find the GCD of 32 and 48, we have a few methods. We can use the dividing method, we can use the Euclidean algorithm, or we can use prime factorization. 32 would be 2 to the power of 5, and 48 would be 2 to the power of 4 times 3. So to find the GCD, we would find the exponents that both of these have in common. Now, 2 to the 5 doesn't have a 3 in here, but it does have 2 to the 4 contained inside of it. So we'd say 2 to the power of 4 is the GCD, which is 16. So now, once we have the GCD, we can divide these by the GCD, and you'll see why. So this is 2 times 16 and 3 times 16. And hopefully this is a little bit more obvious what we're going to do now, because these two already have a 16 in common. So we know that our LCM is also going to have a 16. But also, it needs to have a 2, and it needs to have a 3. So the answer is just going to be 2 times 3 times 16. In other words, you can kind of think of it as the GCD times these two leftover numbers when we divide the original two numbers by the GCD. You can think of these as the necessary component from number 1 and the necessary component from number 2. And so to find the LCM, we multiply all this together and we get 96. Now, a little tiny bit different way, it's not really different at all, but it's kind of different in the way that you think about it, is to just divide one of these two numbers by the GCD and then multiply the other number by what's left over. Of course, you can realize that this is really just doing the same thing, but it's a little bit quicker sometimes. For example, if I know that the GCD is 16, then I can do 48 divided by 16 is 3, and then just 32 times 3. Or 32 divided by 16 is 2, 2 times 48 is 96. Those things like that. So hopefully we know how to calculate the LCM, but if you don't, that's fine. We're just going to get a little bit more practice. So for example, to calculate the LCM of 24 and 56, of course, first we have to know the GCD first. Once you get a little bit more experience with this, the GCD is kind of muscle memory. You can kind of just look at it and tell what the GCD is. But in case we're not at that point yet, that's totally okay. We can do it manually using prime factorization. So 2 to the power of 4 is going to be 2 to the power of 3 times 3. And 56 is going to be 2 to the power of 3 times 7. And hopefully we see now, when we prime factorize it, what do they have in common? It's just going to be 2 to the power of 3. And also, what's different about them is it just has a 3 versus a 7. So our final answer is just going to be 3 times 7 times 2 to the power of 3. Or in other words, 21 times 8, which is going to be 168. Now, of course, the other way you can think about this is, if I were to look at this problem, what I would think of is I see 56, I instantly think 8 times 7. I see 24 and I think 8 times 3. So know that the GCD is 8. Now, 56 is 8 times 7. And so to make 24, if I want to multiply it by something and have it be also a multiple of 56, I need to multiply by that 7. So I might think that the answer is just going to be 24 times 7, which is 168, which would be correct. Or alternatively, I might look at 56 and I think, well, 56 already has an 8, just like 24, but 24 has a 3. So I need an additional 3 on that 56. So it'll be 3 times 56, which is also 168. That's how that works. A little bit more practice. What is the LCM of 24 and 42? Well, let's try using a different way of calculating the GCD first, like the Euclidean algorithm. So 24 and 42, if you remember, the Euclidean algorithm is just at every step replace the larger number with the remainder when you divide the larger number by the smaller number. So here we would replace 42 by the remainder of 42 over 24, which would be 18. Then we replace 24 with the remainder of 24 over 18, which would be 6. So we have 6 and 18, then replace 18 with a 0, and once we've reached 0, the larger number is simply our GCD. So now that we have our GCD, which, of course, if you have more experience, you don't have to do this, you can kind of eyeball it, but this has a rigorous way of calculating it. So we have our GCD, then we think, okay, 24 is 4 times 6, 42 is 7 times 6, so our LCM would be 6, that we have in common, times 4 times 7. 4 times 6 times 7, or in other words, just like 24 times 7, or 42 times 4 would just be, once again, 168. So actually, same answer for both of these problems. 24 and 56, 24 and 42, because fundamentally, the problem between 24 and 56 and 24 and 42 is that 24 doesn't have a 7. You can kind of think of it like that. And so to solve the problem, the solution is the same, to multiply 24 by 7. That's how that works. And now we have also a very interesting idea, a link between the GCD and the LCM, and also a pretty common kind of problem that number sense is going to give you. What is the product of the GCD and LCM of some two numbers? Now, the naive method is, of course, to calculate the GCD and the LCM and multiply them together. And there's nothing wrong with that because that gets you the correct answer, but really there is something wrong with that, and it's that it wastes time. Because there's a very important property of the GCD times the LCM. Can you figure it out? Well, let's look at maybe these numbers. 2 to the power of 3 times 3 and 2 to the power of 3 times 7. Now, to get the LCM, all we did was take the GCD. So, GCD times number A divided by the GCD times number B divided by the GCD. And this was our LCM. So the GCD times the LCM is just what we get when we add another GCD over here. But wait, look, this GCD cancels with this, all of this cancels, and all we have is A times B. The product of the GCD and the LCM of two numbers is just the product of the two numbers. So when we see these problems, just don't even bother calculating the GCD and the LCM. Just multiply the two numbers because it is a fundamental property of math that, the GCD times the LCM is just the two numbers multiplied. So all we have to do is multiply 15 and 35. Now, you have a few ways of doing this. You can kind of think of maybe 15 times 35 as being 350 plus 175. That's a possible way of doing it. When I see this, what I would think of is 25 minus 10 times 25 plus 10. So a throwback using the difference of squares. I personally really love to use the difference of squares. It's up to personal preference. But if I were to see this, I would instantly think of difference of squares because this is 25 squared minus 10 squared. Hopefully we have these memorized. It's 625 minus 100, which is just 525. Of course, the way you do it doesn't really matter as long as you get it correctly and accurately and quickly. But this is the method that works best for me. So it's 525. And similarly, if we have another problem, the product of the GCD and the LCM of 18 and 45, just multiply the two numbers. So if I have 18 and 45, here what I would consider doing is double and half. So divide one of the numbers by 2 and multiply the other by 2. In other words, give like a 2 from one number to the other number. So divide 18 by 2, you get 9. Multiply 45 by 2 and you get 90, and 9 times 90 is much easier than 18 times 45. You get 810. Of course, once again, this is just me showing my thought process with multiplication for a little bit of review or in case you guys need inspiration. But if you already have a system that works for you, these connections in your brain that are unique to you, of course, you can use those. It's just personal preference. So this is the LCM. Really, the LCM is a very similar idea. And the way we calculate the LCM, just to recap, is finding the GCD and then gathering the other quote-unquote necessary components. You can do this by, for example, looking at 24 and 56, finding out the GCD is 8, and you think about it. From 56, we need a 7. From 24, we need a 3, so it's 3 times 7 times 8. Also a very important property, the GCD of two numbers times the LCM of those two numbers is always equal to the product of those two numbers. So this is just an overview of the LCM, how it relates to the GCD, and that's all you're ever going to see of this in number sense. So I hope this video was helpful to you guys. Thank you guys so much for watching, and I'll see you next time.